Hello everyone, welcome back to our channel Problematical. Today we'll discuss solved examples of chapter 5, complex numbers and quadratic equations from class 11th maths NCERT. So the first question is, if 4x plus I into 3x minus y is equals to 3 plus I into minus 6, then you have to, where x and y are real numbers, and you have to find the values of x and y. Now, your left hand side and right hand side both are complex numbers. They are represented in complex numbers as 4x real part plus I times I into imaginary part is equals to 3 plus I into minus 6. Here the real part of your LHS will be equated with the real part of your RHS. Real part of LHS is 4x, real part of RHS is 3, so your x becomes equals to 3 upon 4. Similarly, the imaginary part of your LHS will be equated with the imaginary part of your RHS. Therefore, 3x minus y will be equated with minus 6. 3 times x, the value is 3 upon 4 minus y is equals to minus 6. 9 by 4 plus 6 is equals to y. The y will be equal to 24 plus 9, 33 upon 4. Next, express the following in the form of a plus bi, that means in the form of complex numbers. So, first we will multiply them. It means minus 5i. This is multiplied by 1 upon 8 into I. This is equals to minus 5 upon 8 into I square. Now I square is equals to minus 1 because your I value is equals to root of minus 1. Therefore your I square will be equal to minus 1. You can place this value here. We have minus 5 upon 8 into minus 1. This is equals to plus 5 by 8. Now there is no item over here that you just obtained. You didn't obtain any item. So we will write this as I into z. Real part plus I into imaginary part. Second, minus I into 2i into minus 1 upon 8 into I whole cube. So minus I into 2i. So this is minus 2i square, and I square is equals to minus 2i square into minus 1 by 8 is minus 1 by 8 whole cube will be minus 1 upon 8 into 8 into 8 into I cube. We know that I square is equals to minus 1 and I cube is equals to minus I. This is equals to minus 2 into minus 1 into minus 1 upon 8. 1, 2 can be cancelled with this 4. 64 into 4 to 56 into I cube is minus I. Minus 4 times it will be positive, so you will have I upon 256. This can be written as 0 plus I into 1 upon 256. Express 5 minus 3i whole cube in the form of a plus ib. This is whole cube, so let's solve this. 5 minus 3i whole cube, a minus b whole cube is equals to a cube minus 3a square into b plus 3ab square minus b cube. So This is equals to 125. 25 into 3 into 3. 25 into 9 225. So 25 into 10 is 250. 250 minus 25 is 225 into I plus 15 into 3 75 into I square. Hold on. Plus 3 square 9. 9 into 3 27. 27 into 5. 27 into 5 would be 270 divided by 2. This is I square minus 27 into I cube. Now we know that I square is minus 1 and I cube is equals to minus I. So this is 125 minus 225I minus 135 plus 27I. Calculating this, you get minus 10 minus 198 into I. This is your answer. 5 minus 3I whole cube. Next. Express this in the form of a plus ib. So you have minus root 3 minus of root of minus 2 into 2 root 3 minus I. This is equals to minus root 3 minus a root of minus 2 can be written as 2I, root 2 into I. Because root of minus 1 is equals to I in one bracket and 2 root 3 minus I in the other bracket. We'll have to multiply this. Minus root 3 into 2 root 3 will be equal to minus 6. Again minus minus plus root 3 into I minus 2 root 3 into this one 2 root 6 into I plus root 3 into I square, which is minus 1. So you have minus 6 minus root 3 plus root 3I minus 2 root 6 into I. Is there any problem? Here it should be 2. So you have plus 2 root 3 this is plus. This is plus. It is minus root 3. Minus root 3 into 2 root 3 will give you minus 6. Minus root 3 minus I will give you plus root 3I. Plus 2I into 2 root 3 will give you positive 2 root 6 into I. This will give you negative right. So here it will become positive and this will become positive. Right. So you have minus 6 plus root 2 is your real part. And then you have plus root 3I common 1 plus 2 root 2. Okay. If you want, you can write the I afterwards. So this is a plus ib form. Next, find the multiplicative inverse of 2 minus 3i. So let z be 2 minus 3i. Multiplicative inverse is given by z inverse, which is equals to z bar upon mod of z whole square. Now, for this you need z bar. Z bar is the conjugate of it. It means the real part remains as it is, and complex part's sign gets changed. Next you need mod of z. Mod of z whole square. So mod of z is equals to mod of 2 minus 3i, which is equals to root of a square minus b square, and a value is equals to 2, which is 2 square, plus b square is minus 3. So minus 3 whole square is 9. This is equals to root 4 plus 9 is 13. This is mod z. Mod z whole square. Mod z whole square will be equal to 13. Placing these values here, you have 2 plus 3i upon 13. This can be written in complex form as 2 upon 13 plus 3 upon 13 into I. Next, express the following in the form a plus ib. So, five plus root 2 into I upon 1 minus root 2 into I. To express into a plus ib, you need to rationalize the denominator. So this 5 plus root 2 into I upon 1 minus root 2 into I multiplied by 1 plus root 2 into I upon 1 plus root 2 into I. This is equals to 5 plus root 2 into I let's multiply in the numerator itself. So you have first term multiplied by second term, which is 5 into 1 plus 5 root 2i plus root 2i plus 2i square, which is minus 2. Upon a square minus b square, 2i square. I square is minus 1. So this will be equal to 3 plus 6 root 2 I upon 3. You can take 3 common in the numerator. You will be left with 1 plus 2 root 2 I, and this 3 in the numerator will get cancelled with the denominator. Next, second part, I to the power minus 35. Now this can be written as 1 upon I to the power 35. Again, this is equals to, now you can get into the multiples of 4 or multiples of 2. So this can be written as 35 is equals to 34 plus 1, which is I square to the power 17, which is 34 into I square is minus 1. Minus 1 will be to the power odd number, will give you minus 1, which is minus I. Now this can be rationalized again to get I upon minus of I square. I square itself is minus 1, so I upon minus of minus 1, which is equals to I. Next, represent the complex number in polar form. Now, polar form means in terms of r and theta. So all you have to do is get the values of r and theta. So z is equals to 1 plus I into 3. Here, in general form, z is equals to a plus ib. So a is equals to 1 and b is equals to root 3. Now, your a is equals to r cos theta and your b is equals to r sin theta, which means the 1 is equals to r cos theta and root 3 is equals to r sine theta. This is equation 1. This is equation 1. Equation 1 whole square plus equation 2 whole square. So you get r square cos square theta plus r square sine square theta is equals to 1 square plus root 3 whole square. Here you have r square cos square theta plus sine square theta is equals to 1 plus 3 is equals to 4. So here r square is equals to 4. Implies r is equals to plus minus 2. But your radius is always positive, so it will be considered as positive 2. Now, if r is equals to 2, then 1 is equals to 2 cos theta and root 3 is equals to 2 sin theta. Now, here you can either apply your observation or you can calculate tan theta and then get the value of theta. So, your cos theta is equals to 1 by 2 and your sin theta is equals to root 3 by 2. Now, this is only possible for 60 degree. 60 is 5 by 3. So theta is equals to 5 by 3 by observation. If you cannot observe and if you do not get a standard angle, then you will find tan theta. Tan theta is equals to sin theta upon cos theta, which means root 3 upon 2 whole upon 1 by 2. Solving this, we get the value of root 3 and we know that tan of 5 by 3 is equals to root 3. Hence, theta is equals to 5 by 3. Now, we have the value of r and theta. We need polar form. Polar form is equals to r into cos theta plus I sin theta. Just substitute these values. 2 into cos 5 by 3 plus I sin 5 by 3. You do not have to solve it. This is your polar form itself. Because if you solve it, you will end up with the original given equation. Z is equals to 1 plus I root 3. Next, convert the complex number root 16 upon 1 plus I root 3 into polar form. So, first we will convert it into A plus IV form. Then we can convert it into polar form. Let z is equals to minus 16 upon 1 plus I root 3. You'll have to rationalize it. So you have 1 minus I root 3 upon 1 minus I root 3. You can multiply this. You have minus 16 into 1 minus I root 3 upon A square minus B square. 3 into I square. I square is minus 1, so denominator will be equal to 4. Minus 16. 1 minus I root 3 upon 4. 4. Introducing minus 4, you have minus 4 plus 4 root 3 into I. Or I into 4 root 3. Here your A is equals to minus 4 and B is equals to 4 root 3. Therefore, your R square is equals to R cos theta and 4 by 4 into root 3. Four into root 3 will be equals to R cos theta. R square cos square theta plus sin square theta. So I've squared, added and taken R square common, you have minus 4 whole square plus 4 root 3 whole square. So this is equals to 16 plus 4 into right. So your r square will be equal to 64 and r will be equal then to positive 8. Radius will never be taken as negative. Cos theta is equals to 4 upon 64, 8, 4 upon 8, which is equals to 1 by 2. And sin theta is equals to 4 root 3 of 8, which is equals to root 3 by 2. Your cos value is, this is minus 4, minus 4, minus 4, minus 1. Okay, so cos value is equals to minus 1 by 2 and sin theta is equals to root 3 by 2. Cos is negative and sin is positive. This is second quadrant. Now cos is 1 by 2 half 4 pi by 3, 60 degree. So pi minus pi by 3. Cos pi minus pi by 3 is equals to minus 1 by 2. Cos of 2 pi by 3 is equals to minus 1 by 2. At the same time, sine of 2 pi by 3 is also equals to root 3 by 2. Here, your polar form would be r into cos of your angle. Next question. Solve x square plus x. You have x square plus 2 is equals to x is equals to 0. So x square is equals to minus 2. Second. Yeah. Square is equals to minus 2. Therefore, this is equals to 2 into I. Minus 1 can be, sorry, is equals to minus 2. X is equals to root of minus 2, which is root 2 into I. X square has to be plus minus. So we will have to write plus minus over here, plus minus over here. So you have two values of x, either plus root 2 I or minus root 2 I. Second, solve x square plus x plus 1 is equals to 0. We know that we cannot solve this by Mitchell splitting method. One cannot be split so that the addition is 1 itself. Therefore, you have to use quadratic formula. Quadratic formula is x is equals to minus b plus minus root of b square minus 4ac upon 2ac. Minus 1 plus minus root of b square, which is 1 square minus 4ac, 4 into 1 into 1, upon twice 2 into 1 is equals to minus 1 plus minus I root 3, because you get root of minus 3. So this is root 3 into root of minus 1, which is I. upon 2. You can write this in general form, minus 1 by 2 plus minus I into root 3 by 2. Next, solve root 5 x squared plus x plus root 5 is equals to 0. Again, you cannot split 5 such that your addition is 1. The value of x is equals to minus b, which is 1, plus minus root of b square minus 4 ac put upon 2 into a minus 1 plus minus root of 1 minus 20 on 2 root 5. Root 5 has to be rationalized. You do not want root 5 in the denominator. For the time being, we can leave it. We can do it in the final step, or we can skip it as well. This is equals to minus 1 plus minus root of minus 19 upon 2 root 5 equals to minus 1 plus minus 19 into I upon 2 root 5. This ends your solve examples. Thank you.